Hello, this is the Tepid Coder here. I thought I should probably, I don't know if I want to call this a mission statement or what, but I should probably kind of give an overview of my plans for this channel. I got a comment earlier today suggesting that this wasn't a very useful C++ tutorial, and they're right so far. I've been tagging all of these videos when I release them as being C language, and C++, and I don't know if these tags are actually visible, I guess, in the video itself when you look it up, but I probably should be including in each of the video titles more what I'm going for. So while this is a C++, what do I say? I don't want to call it C++ tutorial. It's aimed at C++ eventually, essentially. So I think that C++ is very difficult to start with. And part of the reason for that is the syntax. You'll have things like, so you have a class, right? And you'll have your constructor, and you'll have your destructor. It has to be public. You have some private stuff over here. Private. Alright, you might be deriving from something, so your base class or whatever. There's just a lot of things you have to think about, and there's a lot of symbols to learn here. Like, you see this usually it's a function call, you're defining a function, so I mean, that guess kind of makes sense, but there's no return type here, it's kind of weird. And sometimes when you define like a method inside the class, it's going to have a return type, int method. It can take some, arguments, do you want whatever. And you have to memorize, like, the class name, colon, whatever. It's the same for that. Constructor. And, like, for the destructor, it's going to be different. Like, that's a lot to memorize, I think, when you're just starting out. And there's things like, if you have a pointer in here, and I've explained this in other videos, and I don't want to go over this all again. Up to this point, though, the video won't have been released yet. But, like, if you have a pointer in here, it's just going to copy the address of this pointer if you copy, and it's going to let you copy by default because it's automatically going to make a copy constructor. There's just so many things hidden from you that you won't know about, won't expect. It has to be taught to you. I really want to make this as simple as possible for someone who's just starting out, like my nephew. And the easiest way to do that is to talk about really basic types. You got your primitives, right? Like your integers or whatever, your characters, your wchars, whatever it's going to be. And it's like, okay, well, how do I print them out so I can check that this is working, right? So the next thing I wanted to do is just like, well, printf, And the reason I like printf instead of standard cout, I explained this in a comment in YouTube comments, but if you do cout and you have something like a unit 8p, it might not have a type detection for that, right? You might actually have to cast this into an int to even use it, but then it's going to be unsigned, so maybe you need to be an unsigned int, and like, how big is the unsigned int? Well, it depends on your architecture. There's so many things about this you don't know, whereas if I just say, look, use printf with a percent sign, and then you're going to say it's explicitly going to be a signed 16-bit integer, right? You know exactly what it's going to print out. There's never any mistakes. There's never any confusion. It's just easy to work with. And now I know you could use standard V format, right? And you could also do a string that has some kind of specifier in here, like if you wanted to print like 2 decimals of a floating point or something. You can do things like that, right? And that's totally cool. But this is still more difficult to do than like this versus memorizing standard colon. I mean, you can obviously use using namespace, std, assuming, everyone remembers to do that, but my nephew might forget to do that and still be confused when it doesn't see that this exists in any namespace or whatever. Okay, use a global namespace, right, if you didn't specify. But then you also have to type like make format args. Okay, and you put the stuff in here, right? This is a lot more to remember than just this. And I want to get him started out. I want him to be able to just start coding right away, get used to it. I want him to be able to do things like arrays of primitives, like you have int I or a for array, let's say, and you have 10 of them. And I want him to know that you can go from 0 to 9, right? I want him to know how to access that array by doing some subscript, or maybe you can do a pointer to a. If it's an int, pointer to a equals and a 0, right? Or just a, because it's already an array of something. And I want him to know that he can just increment that pointer to the next element, right? Plus plus. Now you're pointing to the second element. You can say, I want that element. There you go. And once you're familiar with these things, it gets pretty trivial to move on to the next step once you have C++. Like, once I've explained that you have, I don't know, some type pointer, call it x equals, a type pointer to a block of memory, malloc, I don't know, 10 bytes, right? Then you have to free it. Once I've shown that, it's like, well, dang, that's kind of annoying, especially with the typecast and everything. But when you learn you can just do something like standard vector or type, v, it's like, okay, v dot resize. I want it to be 10 bytes, I want it to be all 0 to start with, right? assuming this is some integer type, right? Or it can be zeroed somehow. Let's make it a char, just for the sake of things, right? Make this a char too, right? LPC or something. Once he sees this, it's like, well, cool. I don't have to remember how to free it, right? I don't have to remember to free it even. Once this goes out of scope, like, it just does it for me. So this becomes easy. When you just jump in here and you see all this std : whatever, bracket, whatever, it's kind of confusing. It's a lot to look at. It's a bit much. And memorizing all of these methods of the vector is also its own ordeal, versus just memorizing malloc for everything, for all types, calloc for all types. Here, I mean, it's vector for all types, but inside the angle brackets. But, I don't know. I mean, there's something beautiful, too, about the simplicity of this, because I can actually just say, this is pointing to a character. If I dereference it, it is a character. This is pointing to... well, it's not pointing. I mean, this holds the address of a class in memory somewhere. And if I want to access the data that it holds, I have to do things like v.data. I'm calling a function to get the data out of it. The type of the data is going to be a char pointer, because it's holding, you know, a pointer to that block of memory. And you can do that, right? And that's going to be functionally equivalent, but I just want to start here and arrive here. And once I have that, you know, I also want to be able to do things like show them how to make a class, right? If class C, whatever, you can construct it within a scope, right? You're saying I want, you know, some class, let's see, and your variable name is like some name. I want them to know, like, hey, when I do this, the default structure is being called, and or constructor. I mean, when it goes here, it's going to call the default, well, not default, just the destructor. And then if I do something like, I don't know, make a pointer to it and say I have a new instance of this class, now I have to delete it. It's like, okay, we're back to that same problem, right? Delete C. If I was making a bunch of these, maybe it's making, you know, a bunch of these classes, right? Do 10 of them, right? Do 2 of them and initialize them with something, you know? And it takes an integer for the constructor for each one. I don't know. Point being, once I show that, then it's like, okay, well now we can get back to where we just were with it being scoped by doing standard unique pointer of, you know, the class type equals standard make unique C and pass the args, right? Have to give it a name here. New pointer to class C, whatever. And this is also scoped, right? I mean, this object dies when it hits this, and everything that this manages, which is this class, which is going to be of type C pointer, if C is a class, right? That's going to be called, we free with delete, so it's going to call that. And if I did this, you know, pointer to an array of them, and I made a whole array, you know, it would call this automatically. I'm building to it, essentially. And the reason I'm making this video now is because I think it would be good for people to know what I'm kind of planning on doing. I have had kind of a, what do I say, a list of things that I want to talk about, and then a lot of the time I'll find that these things have prerequisite knowledge you need to have in order to use them or explore the concept or learn from it in a meaningful way. So I want to go through this list real quick. I probably should have started with that, honestly. If you have primitives, right, that's a great thing. How to format them, that's great. I think this is just the best place to start, period. Arrays, I mean, you might say, well, great, we have arrays of primitives, but what about structures? Is there going to be something different about array of structures? Maybe. I mean, you could say it might be a bit harder to have struct s, and we call it x here, and you have like, okay, x dot something, right? But if you have an array of those, 10 of them, suddenly it's, you know, x bracket dot something, and you have some number in there. So it's sometimes not really clear where I want to express arrays. Do I want to say it before I've shown structures, so I can show arrays of primitives and structures at the same time? Or do I want to show primitives, then arrays of primitives, and then show structures, and then maybe say also you can do some structures? That's kind of ambiguous. They could both be the right answer. I mean, I don't think there's any right or wrong answer in that case. Let's see, initialization of a structure. Yeah, I mean, no one wants to have to type out, you know, the structure dot, you know, member 1 equals something, right? Dot member 2 equals something else. Whatever, all the way down. And they have a new instance of structure called structure2.m equals whatever. It's nice to just put that into a common function, you know, init structure, right? And then you put a reference of it in there, and you put the member arguments, right? And it's great because then it's a natural step from that to a constructor. And I know some people might be thinking, well, why not just start with a constructor? Why not start with a class? If you had a class object, you could just put that initialization step in the constructor, even make it so that the, you know, the structure itself could have default values, right? You know, tm equals whatever, equals t, some value. You could do that. You could do it in classes too. There's nothing stopping you from doing that. And you can also do it with initializer lists. You can also do it inside the constructor with arguments. And I want to cover all that, and I actually have in a lot of videos that just aren't released yet. I'm going to show that real quick. Here's all of the code that I've written for different videos. Not all of these are released yet. I have a whole segment on just DLL files, SO files, .lib files, whether it's just static link library or whether it's an import library, .a files being kind of the same thing. This one I didn't actually decide to release. I don't like my explanation there. I was kind of talking about, like, there was an ABI break between standard C++ 11 and what came before it. So if you use standard string in a library, you wouldn't even be able to link against the library because it used a different version of standard string. You had to recompile it, and it was this huge mess. Anyway, it was kind of hard to explain that in a comprehensible way, and I don't think it was good enough to be suitable for public consumption. Anyway, yeah, let's continue this list here. So initializing by function using reference to structure, initializing with default values, like I just kind of showed up there for a second. With the constructor, I mean, I've already shown all of this at this point. Not with the videos that are released so far, mind you. I think I've pretty much covered this. Create them for primitive structures. Create them for function pointers. This, yes, I have actually done that, but not in a video I've released yet. Access subscript, I've definitely shown that. So function C-style, this is all I've been showing so far. But in a video I haven't released yet, I have talked about function pointers, and I've used like qsort versus standard sort, and talked about how you can use lambda functions for that. Let's see, class methods. Like, what I'm saying here, the difference is just like, well, like I showed it right here, the return type, the function name, the arguments it takes, versus like, you know, class name, colon, method name, and then, you know, t2, whatever. And over here, you also have your return type. And I even showed that for templated functions. The templates, I haven't shown them yet as far as uploading them to YouTube and having them released, but they're there. They're queued to be released on a different day. Okay, so templates. We have templated functions. I have already made a video for that. Breaking templates into multiple files. Like, if you try that, it's not going to exist in the object file unless you actually use it, unless you explicitly instantiate it, and there's syntax for that, and I've shown that. That video's probably not up yet. Released yet, I should say. I've definitely shown this. I have a video showing that. I've definitely shown this. I don't know if I explicitly talked about it as its own like standalone syntax thing, but in general, I kind of try to introduce topics broadly, and then I'll try to give code examples of how you might use these concepts. And I think that the syntax comes naturally, and I can talk about it while I'm coding it with a real example. And I think that'll sink in better than just saying, like, okay, you have an integer, here's how you define it, it has this range. Okay, why do I need that range? Why do I need an integer? What am I going to use this for? That's always what I think when I see people explain things abstractly. It doesn't ever help me. I want to see an actual code example that's concrete. Maybe I'm just, like, autistic and have issues with abstracting. I don't know. That could be. Don't know, don't really care. The point is, if it works for me, and I'm the lowest common denominator, it probably is going to work for someone else. That's what I'm thinking. And when it doesn't, I mean, that's what the YouTube comment section's for, and I can expound upon things. That's great. So I'm really thankful for this comment I got, which showed me that I kind of needed to give some kind of, I don't know, video explaining my direction, my approach, which is what I'm trying to do here. I might even record this a couple times until I can get this out in a way that's, what do I say, easily comprehensible and concise. So, yeah, so pointers and references, what this means, how to increment it. Yeah, I showed this, and I also followed up with initializer lists. Like, I'm building to it. Like, it's hard to say, like, why you ever might want to do something like you have a class, and then the class has a private member, which is a type reference, you know? Why would you ever want to do this, you might think? And, like, you can't do that in constructor unless you use initializer list. But this is something that can't ever reference something else. Like, why do you want to point to memory outside the class? And I show a reason why you might want to do that. And I give an example of, like, a nested container with a vector, and then if you have, like, a map of, like, a string to a vector or something, and maybe this vector strings, right? So maybe I have, like, a map of, I don't know, people to friends or something. This is just a contrived example off the top of my head. Like, maybe the type encoder has a friend, and his name is Billy Bob, and he has another friend named Joe, and then both those people would be inside this vector, and, like, you could just reference that, right? I show that in a video, how you can just do, like, standard vector of some strings and reference that. So v friend, let's call it equals, oops, equals, it's going to be this. The position would be like coda, right? And that would just give me the access to that vector itself, and I could reference it this way instead of having to look it up every time by typing this everywhere. So, I don't know, I show examples of that kind of thing, but I wouldn't want to start with that. Geez, if I was just learning C++ today, I would not want to be looking at something like unique pointer of like a reference to some template class, and it's like just this crazy thing. C function pointers, like I said, I talked about that for qsort and standard sort, and you can use lambdas for even qsort if you don't have anything inside here, right? Like a copy of something, or like a reference of something, or the whole scope, you know. But if you want to use like standard sort, you can always add stuff to it with that syntax right here, right? Or copy or something else. And that's because it uses standard function. I showed how you can use standard function yourself. Obviously, I mean, the comment I got that kind of told me that I needed to make this video, I mean, the impression I got from it was kind of talking about why I'm using the C way of doing things like this, right? I think it's easier to understand these, and especially these, once you've done these first. Because this just allocates a block of memory. This allocates a block of memory and actually instantiates an object in it, right? And when I talk about a template class, I make my own version of like standard vector, which is like really primitive though, and it only takes primitive types. And it specifically only takes primitive types, and I explain that because I'm using these functions, which don't instantiate. I mean, there is a function you can call to instantiate a class type at a certain address, and maybe it has to be aligned, and there's a keyword for that, and you know, that's great, but I wanted to keep it as simple as possible and move from there. And later I talk about using new and delete, and after that I talk about, you know, using the smart pointers, right? So like right here I have things I want to talk about as far as pointers. There's unique pointers and shared pointers, but I mean, that kind of has to come like between here and here, right? And that's kind of what I did. I had to shoehorn that in here. So the place to put everything is never always going to be obvious. There's never an optimal way to structure this. And I think for different people, it's going to be a different answer, right? For someone else, it might be better if I explained all allocation functions at once. And maybe it'd be better for someone if I explained it all abstractly and they could just refer to the documentation and look at code examples to figure it out that way instead of listening to me talk for an hour about something and code through it, whatever. But yeah, I mean, the first way I introduce any kind of C++ function, I mean, I might have done some IOStream, like standard cout, whatever, but realistically, the first time I actually use any useful C++ functions is when I'm using standard vector for the video about parsing a file and looking at a bunch of key values, where it's kind of like, you know, key equals value, line 2, you know, key 2 equals value 2, dot, 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 right? And the way I showed that was basically loading the whole thing in memory, which you usually don't want to do. That's a dumb idea. But the whole point was just that I could do it. I could find where all these tokens are, find what the end of the line is for each point. I could zero those out, and then I could just have a block of memory that points here and points here for each line, and these are already zeroed at the end of the line and at the equals, and you could just loop through those and print them. Which is, I mean, it's a cool C way of doing things, but then I move on from that to a vector of structures, which contains a key and a value, which, I mean, at that point, why not just use a map, right? And if I'm going to use a vector, what I was able to show is, like, it's going to be scoped, and when I do in place back, it just adds more memory as it needs it, and when I let it go out of scope, it frees it automatically, so that's great, it's wonderful. I love that about C++. To me, like, that's the only reason I do use C++, is the fact that classes let you scope things. It has a great separation of concerns. But there's also added concerns, too, sometimes, like, when you have to think about copy and move semantics. You have to think about when you're turning something from a function, is there going to be copy elision? You have to think about, you know, am I doing a shallow copy or a deep copy? Because if it's a shallow copy, and maybe I'm storing some memory, that memory is going to go out of scope. Well, I mean, the memory is going to be deleted when the class object is destructed, and if they're both sharing that, the initial class and the copy, and they both go out of scope, or I should say, when the second one goes out of scope, it's now undefined behavior because the second one is freeing the buffer from the same address. Okay. Anyway, there's things like that you have to consider, which you wouldn't have to think about if you were just doing this, because it's only freed when you tell it to free. And if you free it twice, like, it's going to be kind of obvious when that happens. You'll see the problem happen on a free call, not like when a function ends. It's like, well, what the heck? Why, when this function ends, am I suddenly crashing? It's, well, what's because the object got deleted. Well, which object got deleted? And you go run a debugger, and you can find it and watch it step through. And once a destructor is called, you can step through that, and you can see it crash there. And I do want to get into debuggers. I do. Like, that's a really important thing to know when you're actually trying to diagnose some problem. It doesn't help so much when things are multi-threaded usually, but either way, it's useful to know, especially when you're developing some algorithm and you want to watch it each step of the way through and look at the values of each of the local variables. Okay, and like some of the things I have for class syntax, and I've gone over most of this, not in release videos, but I have gone over it. It's a syntax to create one. Like it's, it's like a structure, class, name, blah, right? And I talk about private and public, and I talk about how to define the methods, and like of course I have something about functions over here. Where was that? Functions, right here, like class methods, return type, class name, colon, method name, right? Just building on small pieces one at a time, where like for a C function, it's just a return type, and then the function name, and then it's like the argument that takes each type space the name of the argument, and then comma the next one, and so forth. I haven't talked about variadic functions yet. Maybe I should add that in here. Variadic functions. And I should say C variadic functions, because you do it very different with like VA list and whatnot than you would do with a C++ variadic function, which you might do with some kind of a template, right? And those get really hairy. They're disgusting. It's not even something I'm looking forward to talking about, to be honest, but it's gotten a lot easier with like folding now. With I think, was that C++ 14 that came out or 17? I can't remember. I've done it though, right? I mean, that's great, and that's how you have things like standard V format, right? Those use probably folding their templates and whatnot. That's great. It is. I'm getting to that stuff, but it's kind of overwhelming to talk about all this. Like I said in the comments, I'm not angry about it either, because I totally get where the person's coming from. So far, it has totally been like a C tutorial, because I'm building up to C++. I just don't think it's productive to start with C++ most of the time. But yeah, in the video that I talk about classes for the first time, I talk about the syntax, I talk about what the constructor does, when it's called, like when you first create the object, which constructor it's picking, and how to pick a copy constructor or a move constructor, how to define it, how to pick a move assignment operator, a copy assignment operator, how to define them, how to handle errors in constructors, which in this case I used standard runtime exception, right? Or was it runtime error? Sorry. And I catch it with a, I did standard exception, which, whatever, catch it by reference, right? Exception. So I show that, right? And that's fine. I also say you can also have something where, you maybe set something inside the class where it's in a ready state or it's in a like failed state or something, and you can check that before you actually use it. Then you won't have to wrap things in a try and catch block. And if you do want to wrap things in a try and catch block, and you don't want all your code to be pushed forward, like try, say class, call it C, O for object, boom. You're trying that, and then you're catching an error, whatever. Now everything kind of has to be in here, right? Because once the scope ends, it's going to call the structure for this. It's like, well, you could do this, pull it out, and say it's a new object, and then maybe call delete, either when you're catching it, or you can do it down here, when the time comes. And of course, that was a great segue to say, well, if you're going to do that, you might as well not worry about the memory, because you might as well worry about those cases. You can just do unique, seems like type unique. That's been a persistent problem for me, it seems like, type unique. Equals standard make unique, type C. You can pass it in, you can construct arguments, whatever. So I showed that too, and it's like, that's great. So now you try to actually create it, equals right here. I want to do this. So here it's like a default state, which is uninitialized. You can check to see if not pointer, it'll tell you it's null. But if it fails, I can handle the error and bail out of the function or whatever. But if it doesn't fail, I can just use it, invert, whatever. So I hope you guys will give me a chance here to continue through these videos, because realistically, each video is going to be a very incremental change. In the one where I explain classes, I kind of have to go through all this. I mean, you can get up and running just knowing how to construct a class, right? What's the syntax to make it? How do I do the constructor? How do I do the destructor? How do I add methods? And how do I define them in two files, a header and a CP file? Once you know that, you're off to the races, really. And the rest of the stuff, you can kind of maybe spend 10 minutes watching the video, or you can look up the documentation and find it there too pretty easily. But yeah, I definitely build up to this stuff. And we get into virtual constructors and things, and I talk about, like, if you make a, what do I say? Let's call it B for, let's say base even, so base, B, or I'm going to call it, what do I say? I for implementation, let's say, IMPL, equals, like, implementation, right? You can say the base class has some implementation that comes from it, derives from it, you have to actually make that a pointer and say it's a new version of this, because the base class size might be different than the size of the implementation over here. So you have to store it in a pointer. And class pointers are bigger than normal pointers because it might have to point to a virtual function table and stuff. And I talk about that a little bit, but not too much. But I mentioned that, like, if you're going to do this, again, it's a great time for a standard, unique, or you get shared pointer. Maybe you're going to share it across the code base, and you don't want to actually free it until all instances that are using it no longer need it, right? In that case, you do make shared. It's going to be implementation. Come on. Right? You know, I do show this stuff, man. It's not like I don't know C++. Now, if you try and catch me with some crazy templated stuff, like I said, with folding and whatnot, I have to look things up. I have to look at the documentation, look at examples, and get it in my head every time I do it. And if I'm looking at something like recursive lambdas, oh my god. Nope, no thanks. That doesn't work in my brain too well right now. What was it I tried a while back? It's coroutines, man. Coroutines in C++ is just awful. Syntax is just awful. It's just use a thread. Either that or, I mean, take some code for a coroutine off some GitHub branch where someone's explaining it and alter it heavily to your needs or whatever. That's fine too, I guess, but geez, they couldn't have made that much harder. And there's some things I need to learn too with like MD-span for like modern spawn, MD-span, this new pipe operator and stuff. I do need to get into that. The other day I was actually looking into the new standard file system, which came from the Boost file system, and the way they handle paths and stuff, and you can get it in the native path, or you can get it in like a path that has like double backslash and all the path tokens, right? Like dear 2. Anyway, the way they break that all up is really cool. You can just iterate recursively through a directory. I have classes that I've made that recurse through directories that are platform agnostic, so I can do it on Unix or Linux platforms, and I can do it on Windows with the same code base, and it'll use the right header depending on which compiler I'm building for, or it's going to be GCC or it's going to be MSVC. I could have made it like a define where it picks the platform when you're building it. You know, you do something like GCC -d, you know, some define equals whatever, right? It could be Windows, it could be MSVC, it could be Linux, it could be whatever. And, you know, cl.exe, it has the same kind of thing. I think it's /d or something. And that's cool. I haven't covered threads yet. This is something I want to get to. I'm actually kind of excited about this. Talk about threads and mutexes and stuff. And I might just actually, in the video description for this one, link certain videos from other YouTubers I've seen, which talk about other ways of doing threads, like with OpenCL and using the graphics card. I've done that, but I really don't know if I want to go into several hundred lines of code just to set that up. I have working code that does it, but I don't know if I want to just go over a completed project. I think it's better if I can kind of type it and explain it as I'm typing it, instead of just saying, here's a huge chunk of code to look at, here's vaguely what it does, and then people have questions about one line I didn't go over. If I'm talking about each line as I'm typing it, I think it's better. I'll miss less things. And I'll still take things for granted, right? I'm sure there's plenty of things that I'm glossing over as I'm typing this. But also keep in mind, like, I'm also remembering in my head things I've talked about in the past with my nephew that I may not want to, or may not think I need to go over again, because it's like I remember talking about it. You know, I haven't necessarily gone over it in a video. And I'm trying to listen back to the videos I record, and when I do that, trying to really pretend I'm a listener, and I don't know anything that's being said. And I think, well, what has been said before in the previous videos? And I try to remember that. Like, would I know this? Would this make sense to me? And sometimes you notice yet? Has it been released yet? I don't know. If it's been released, you'll notice that I've been doing follow-up videos for some things, where I explain things in more detail. Like, I know there was one video I made where I talked about, instead of doing, you know, this in whatever some index, you could also do plus n, right? Equals something, or you can grab a value from that, right? And that was, you know, a little follow-up I needed to do because I didn't mention it, and I should have. But yeah, so I'm mentioning libraries and DLL boundaries, where you don't want to return an object from, what do I say, a library that you don't control, because you don't know if it's a common library like standard string or something. They might have a different version of standard string which is implemented differently, and because of the version differences, maybe it'll compile to link against it properly. But even though it can link against your library and make an exe, it might be using some undefined behavior, and it might cause a crash at some point, or memory corruption, and whatever. So in general, I mean, I do talk about how you don't want to basically call free, or alloc, or new, or I should say delete, rather. or delete like this, or have it implicitly called with a smart pointer, right? If you got the memory from a DLL. And also, I mean, in one of my videos I talk about how you want to make sure that in your build process, every time you update your compiler or switch to a different compiler, using the same compiler and the same same version of the compiler for every single dependency you have that's been linked in. Otherwise, you can cause problems. This is something I'm really not enthused to do, but linking with third-party libraries, every single one's different. They all have their own build systems they want to use. Sometimes they have to have like certain defines that are set at build time, and it's based on the platform, based on the functions you want. You can have a lean build or a debug build, and geez. I'm the kind of guy, it's like, I'd rather maintain multiple build systems. It's not that much more effort to have like, okay, here's your CMake approach, here's your Microsoft Visual Studio approach, here's your whatever Xcode project solution. I mean, I know there's issues with that too, because you might have to set up inside the actual project file where your libraries are. There's like a, what is it, exe proj? Something like that? Or dot that or something, or dot settings? I don't know. But it's a configuration for Microsoft Visual Studio that tells it where to get the source files, where to link libraries, and all that kind of stuff. And that might be different for different people's systems. So it ends up being more complex sometimes than just using a build system, but I find that not to be true usually on Windows, for me at least. Sometimes it's true, sometimes it's not. I think on Unix systems, CMake tends to shine a lot more. But, geez. Yeah. If I release this, I'm going to chop it up. If I don't release this video, I'm going to just re-record it. But essentially, I just want people to know that I'm doing this in a way that I feel builds upon itself. Building from simplicity to complexity, where it's needed. And one thing I probably should add in here too is biases. Right? Dislike cout and cn and fstream. I don't like these. I really, really don't like these. In fact, there are things I don't like inside of like Boost, for example. Like Boost Beast has like what's it called? Read sum. I'm trying to think. They have these flat buffers they do some stuff with, and it returns string views, and it's sometimes difficult to get the actual string itself sometimes. And everything is like a proactor model where you're basically putting things inside of a shared pointer to keep it alive, and everything keeps trying to push forward to the next function to keep the task list alive and to keep doing things. I'm not really a huge fan of that, to be honest. Doesn't mean I won't necessarily show how to use it, but if I think something's bad to use, I'm probably going to, I mean, as you've seen, I tend to stick with fprintf a lot, even though this C++ way might be the format, right? If I don't see a good reason to use this, honestly, I'm not going to. Like, that's not going to change. There are times where it's nice, where like I'm not sure how big something needs to be, and I just want to format a string into an actual string variable and store it for some time. Like maybe I have a class object, right? And inside the class, there's like, you know, imagine I'm inside a class, and here's my private stuff, right? And I have some string, I want to make a reference, last error or something. Oops. Right? And in this case, maybe I have a method that returns like, you know, get last error, you know, returns, I'll do const, right? Const, standard string reference, const. You know, and this is, I don't have to actually type the void there, I know that in case someone's wondering. I don't actually have to do that, but I do. And they can get at this error. Like, vformat is a great reason for this, or a great thing to use for this, because I don't know how long the error message might be. I might have to have something really descriptive for one method that failed, or I might have to have something that's really short for another method that failed. So, yeah. Yeah. Anyway, I'm going to stop this here for now. I'm going to listen back to what I said, and if I don't like it, I'm going to redo the video. Anyway, as always, I appreciate any kind of feedback, even if it's critical. I really mean that, because if one person has something that they're not getting about it, it's possible other people have issues with it as well, and that's something I should fix. And it could be possible that this video series is just going to be too slow for some people. I think it's going to pick up pretty quickly, though, the next... I don't know exactly which videos are being released when, but I scheduled a couple videos per day, you know, for the foreseeable future. But yeah, I think by the time I get to, like, the first example of C++ classes, people will be pretty happy with it, or be annoyed when I'm stumbling over my words and use the wrong word for something. That could be the case too. Oh man. Anyway, hope you guys have a great day. Thanks for watching.